This is saying the graph of f, shown above, consists of two line segments and a semicircle. Woo! G is this integral. What is g of 5? What did we talk about on Friday? If this x was replaced with a 5, what can we do with that x? Replace it with a 5. So I'm going to say g of 5, oh, that's really fat, okay, is from 0 to 5 of f of t. And all this integral means, you guys, is just the area under the curve. Area under the curve from 0 to 5. And so I think this picture is very misleading. How many people want to go like this? Oh, let's go find the area of that triangle and that semicircle. Why is that not what they asked for?
It's from 0 to 5.
From 0 to 5. From 0 to 5. They want us to keep off that left part of the triangle. Rude is what I would say to that. So that's just us being mindful of the bounds. From 0 to 5, let's go find the area of that first triangle. What's the base? Base is 1, height is 3. Plus the area of that semicircle, pi what squared? 2 squared divided by 2, because it's a half circle. I would say half of 3 is 1.5. Plus, how many pi's would this get me? 2 pi's, because it'd be 4 pi over 2, which is 2 pi's. Is that an answer?
Yep, that's D.
That's D. Did they have it if we included the rest of this triangle? 1/2, 2 times 3, 1/2 of 6 is 3. Was 4.5? Yeah, right there. Rude. Okay, this next one, the graph of f shown above. F is shown above, and then g is this integral. And it says, at what values of x between 0.5, that looks like 0.5 is where my graph starts when x is 0.5, and 6.5 is where it ends, do we have a max? Does g have a max? For g to have a max, what does g prime have to do? Yes, I'm going to even write myself a little note. G prime from positive to negative. That's how we get maximums. Well, if this is g, could we go get g prime? Not even looking at my picture yet.
G prime is
F of, so close. G prime of x, bless you, bud. G prime of x. The derivative of this integral cancels out. I agree with that. So this is gone. But we got to plug in our bounds, right? Yep, so it's going to be f of x times the derivative of x, 1, minus f of 1 times the derivative of 1, which is 0. We cool with that? This is what they want us to pick up on. We're looking for, what we already said, was when g prime goes from positive to negative. Well, g prime is just f. We just wrote that. G prime is f, so we're really looking where f goes from positive to negative. Where on this graph does my f values go from positive to negative? What x? Just at 3, right? Positive to negative right there, boom. Does it make sense if we're starting at 1 that we would have had the most positive area from 1 to 3? Because that's what this is saying. Where do we have a maximum? Maximum's that positive. This is my most positive area from 1 to 3. If I were to keep going from 1 to 4, I would have taken some of that away, right? So we're going to say from 1 to 3. Okay, let f be this function. Ooh, and then we're going to need a calculator for this. Let's go use our calculator. Okay. Okay. What makes a function increase? What makes a function increase if what's positive? If, well, don't forget, hold on. Right, because this would be, if this is just f, all of these are positive, right? But it'd be decreasing here. So my function is increasing if f prime is positive. You guys, could we use our calculator? Well, let's find f prime by hand first. Yeah. Then we'll use our calculator. If this is f, what's f prime? If I had to take the derivative of this integral, what's going to happen?
Would cancel out the derivative.
Integral's going to cancel out. We say bye-bye, and we'd be left with?
The function with x.
Exactly. So you're saying negative x squared plus 2x plus 3?
Well, you then need to add the other bit.
So we would say times the derivative of x for chain rule, which is just 1, minus, to your point, we'd have to go plugging in a 10, but times the derivative of 10?
0.
Yeah, so we really don't need to worry about that, but that's good memory, Koopy. So you guys, if I were us, Let's go graph just this function. I don't want you to type math 8 or math 9. We found f prime. Let's go type that in. Let's go type in, we got negative x squared plus 2x plus 3. And if I do a zoom 6 window, wow. So everyone else's look like this, a little zoom 6.
Yeah.
And it says, where's my function increasing? Guys, didn't we just graph f prime? And we said where f prime is greater than 0. I'm going to just go ahead and sketch myself this graph, just so I have it to look back on. And this graph was a little something like this. It just went, woo! And this is a graph of f prime. We said that's what we need it when my f prime is greater than 0. Where do you think we've got to look? Whoops.
You got to look at the points where they cross the x-axis.
Yeah, and above or below?
Above.
Above, right? We're looking for these values right here. We're looking for that interval. So when you said we're looking for the points where it crosses the x-axis, let's do second trace. Option 2 is 0. Go to the left, enter. To the right, enter. Bless you.
1, -1.
You got -1?
Yeah.
I agree. And then did we do the one on the right?
It'd be 3.
It's going to be 3?
Yeah.
Wow, I love whole numbers.
And there's only one that starts with
Oh, interesting. I didn't get a 0 there. Hold up. Option 2. Let's try that again. Why isn't what? This calculator's the worst. You said you got 3 right there?
Yeah.
And you're saying, anywho, it's got to be this answer because it's the only one that goes from -1 to 3. Where is h increasing? For a function to increase, its derivative has to be positive. If here's h, what would we say h prime is? 2 plus 2. Oh my, if I didn't make a mistake on double ln'ing this will be a miracle. I would imagine it's supposed to be ln of t, just one of them, but let's go see if any answers match. You guys, let's go graph this. Note the window that they gave us. They wanted us to change our x-axis from 1.1 to 7. So I'm going to change my window from 1.1 to 7.
Hey, it worked.
It did? And then we got 2 plus 2 ln of x. Let's see if it matches an answer, though. Did we get where h prime is positive? If this is a graph of h prime, oops, let me just do it right here. If this is a graph of h prime, it looks something like this. Where it's positive would be everything in red, correct? Anything above that x-axis?
Yeah.
Okay, so let's go find that 0. Did anyone find that 0?
I did.
You did? It's 1.445?
Yeah.
So I didn't make a typo there. It's a miracle.
Yeah.